Welcome to this video on the Automic Automation AWS Step Functions integration solution. In this video, we will explain the AWS Step Functions integration and what it brings to the Automic Automation user community. AWS Step Function is a serverless orchestration service that integrates with any AWS functions and with third-party systems and APIs to build business-critical applications. With the Automic Automation AWS Step Functions integration, Broadcom provides an orchestrator of orchestrators with all the powerful automation and integration capabilities of Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating AWS Step Functions, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. AWS Step Functions processes can then be synchronized with all other environments routinely supported by Automic Automation. AWS Step Functions' role is reduced to execute the tasks. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the AWS Step Functions environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to start, cancel, and restart state machines in AWS Step Functions without having to leave Automic Automation. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of start and restart jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple ERPs, multiple database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the AWS Step Functions endpoint and login data, and a job template designed to trigger start and restart jobs. Let's assume we're automating for 4 instances of AWS Step Functions. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the start and restart jobs in Automic Automation for each corresponding process in AWS Step Functions. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in AWS Step Functions. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the AWS Step Functions integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. AWS Step Functions is a standard Atomic agent. It requires at least 4 values to be updated: agent name, Atomic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every AWS Step Functions instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the AWS Step Functions REST API URL. Finally, we use the template jobs to create the jobs we need. We match this Automic Automation start or restart execution job to the AWS Step Functions, reference the connection object, and run it. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the AWS Step Functions integration. The agent is included in the installation package, which we download from Marketplace. We unzip the package, which creates a file system agents/AWS Step Functions/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to AE and deploys the object templates needed to support the integration, the con or connection object, and the start and restart execution AWS Step Functions job templates. In our demo, we will create a connection object. Once we have established the connection to the AWS Step Functions environment, we'll create a start execution job. Finally, we'll execute and supervise the job. Let's start with the demo. This is the AWS Step Functions console. This is the list of state machines that are available in our environment. A state machine is a workflow that is a series of event-driven steps. Each step in the workflow is called a state. A task state represents a unit of work that can be another AWS service, like Lambda, or a third-party API. In short, a task step can be any AWS service or any API. As you see, we have multiple state machines in our environment. Let's have a look at one of them. This is this state machine's definition. Some of the fields that you see here will be very relevant for us, like example, the ARN. This is the machine's unique identifier, and it will be used to start the execution on the Automic Automation side. Here we can also see the details of the execution. For example, this particular state machine has several executions. We can see the execution status and the name of the execution. Let's open an execution and see its details, such as the status and the execution ARN. The details also provide a graphical view of the state machine, meaning the steps involved in the execution. If we open the execution input, we can see how the execution input was as well as the detailed execution output. Let's go back to the transaction process page and see an example. Here we can also see the state machine's actual implementation and flow. This process has a start and 2 branches with 2 possible choices about how to proceed and which Lambda function to invoke. On the left pane, there are multiple services available that we could pull and add to the state machine. AWS Step Functions also lets us build processes using code, provided we know the nomenclature correctly. Let's go back now to the executions. In our example, we have selected the purchase branch, which means that this happened in the corresponding Lambda function. Then the execution ended. We can also enable the X-ray tracing option, by which all the traces are logged and can be used to analyze the execution. The execution ARN is essential for tracking the details. Let's go to our Automic Automation environment now. We have already created connection objects and jobs. This is a connection object. we must enter the endpoint, that is, the URL of the AWS Step Functions environment, and the region where the state machine is located. We must then specify a credential method. We have 5 options. With the credentials file path method, you must provide the profile name and the location of the AWS credential file on the agent machine. The EC2 profile instance method allows you to connect to an EC2 VM within an AWS cloud application. You can only use this option if you have an EC2 instance profile. With the secret access key method, we must provide the access key and the secret access key. The external provider method lets us set up single sign-on, SSO, with SAML using either a service or an identity. We must enter the authentication data required to access the AWS system that uses single sign-on, that is, the tenant ID, authentication URL, SAML username, and so forth. Finally, the assume role method allows us to temporarily assume a role and access different services with the credentials that you are assuming. By providing the correct information about the proxy host, name, and password, we can also run the jobs if they are behind a proxy. In our demo, we will use the secret access key credentials type. We have the connection object, so now we can move on to the execution job. Here we have already defined one. This is a start execution job. The connection drop-down list lets us select the appropriate connection object. It is mandatory to select a state machine ARN. The rest of the fields on this page are optional. In state machine ARN, we can either type the name of the machine or select it from the picker dialog. Optionally, we can provide the execution name that we want to use for the execution. Also optionally, in payload type, we can either type a JSON or specify a JSON file that is stored on the agent machine. This serves to pass arguments created at runtime to step functions in JSON format. Finally, we can also provide the trace header to quickly identify the logs related to this job. Everything is configured now, so we execute the job. As soon as the job starts running, we have the option to open its report. This is the list of executions in Automic Automation. As you can see, I have already run some jobs. The job has failed. Let's have a look at the details of the execution. The remote status field in the details panel tracks the status of the job in the target environment. The status will keep changing depending on the status of the execution on the AWS machine. Once the execution is complete, we get the reports and the execution ARN. This is the execution ARN. This is the same as the execution ARN that I showed before. We can use this ARN for further processing by referencing it in other jobs or complex workflows. Let's have a look at the reports now. There are 2 important reports, the job report and the agent log. The job report is printed once the execution is complete, and it contains the information that we get from the AWS environment. As you can see, it prints everything: the execution ARN, the sent input, the received output, the status, and the redraft status. This is the final report that we get from the AWS environment. The agent log provides details about the execution on the Automic Automation side, that is, what happened on the agent while executing. It contains the parameters that Automic Automation has sent to the AWS environment. Once the job starts, the log also prints the execution ARN and the monitoring details, such as all the statuses that the job goes through when executing on AWS. We can track all of these statuses in this report. If something goes wrong, this report contains the exceptions and the stack trace. In Automic Automation, you can restart jobs by selecting the execution and clicking the Restart button. For this to work, the job must be in a retrievable state on the AWS state machine. This way to restart a job allows us to restart only the last execution of the job. If a job fails repeatedly and you want to restart an execution that is older than the last one, you must use the restart execution job instead. The R icon indicates that this is a restarted execution. We can also cancel the execution of a job while it is running on Automic Automation. This will also cancel the execution of the job on the AWS environment. The Details panel contains all the information about the cancel operation. We see here that both the status on Automic Automation and on the AWS environment is canceled. If we want to restart executions that are older than the last one, we must execute the restart execution job. As happened with the start job, we must indicate the connection object that will communicate with the AWS environment and the state machine where the AWS job runs. In execution ARN, we select the execution that we want to restart. If we click the browser button, the dialog displays all the executions available in the state machine that we have previously selected. Let's select one and execute it. The execution details show that the job failed again. The job report of this failed execution indicates the redrive count and the end status, which was failed again. Also in this case, the agent log shows the parameters used to execute the job, its final status, as well as the possible reasons why it failed. Finally, it is also possible to cancel an execution while it is running. This cancels the job both on Automic Automation and on the target AWS Step Functions environment. You can download the agent from the Broadcom Automation Marketplace. Thank you for watching this video.